Okay, here's some more examples with shaded areas. We've got here a rectangle with 4 circles cut out of it. So we find the area of that rectangle and we subtract the area of 4 circles. The rectangle is nice and easy, right? Length times width. Length 24 centimeters and the width 6 centimeters. So 24 times 6 is 144. That's the area of the rectangle. For the circles, we have the formula for a circle area is pi r squared. And there's 1, 2, 3, 4 of them. So there's 4 pi r squareds. And we just need to figure out anything about the circle. We need to know r. So radius is a measure from the center of the circle to the edge, in whatever direction. What we're given here are circles that just barely fit into the rectangle. So we can assume here that the measurement here, 6 centimeters, is the same as the diameter of that circle. So we can say that the diameter of the circle is 6 centimeters. We could do it this way too. 1, 2, 3, 4 of them fit into 24 centimeters, so 24 over 4 is going to be 6 as well. But anyway, the diameter is 6 centimeters, which means that the radius is going to be always diameter over 2, which 6 over 2 is going to be 3 centimeters. So 4 times pi times the radius of 3 centimeters squared. Take 3 and square it, that's 9, multiply by pi, and multiply by 4, because there's 4 circles. We find that the area of the circles is 113. Let's say 0.1 square centimeters. So that's the area of those 4 circles. The 4 circles are being cut out of the big rectangle, so we're subtracting. And 144 minus 113.1 is 30.9 square centimeters is the shaded area. Let's try another. I think this one's pretty straightforward. We've got a rectangle with a triangle at the end of it. So it might be drawn like this, and you have to mentally put in that line. It might be drawn in any other way where there's some kind of shape on the end. There's a semicircle over here, or there's a, I don't know, parallelogram sticking out the top. You might have to make the decision in your mind what to chop it up into, but here it's obvious. We've got one rectangle and one triangle. They are next to each other, so we're going to add those areas together. The area of the rectangle plus the area of the triangle is going to be our total area. For the rectangle, the formula is length times width. In this case, 12 millimeters times 7 millimeters. 12 times 7 is 84. And millimeters times millimeters is square millimeters. For the triangle, this one right here, our formula is base times height over 2. The base is, well, it doesn't matter if we call that the base or that the base. One of them though. The base is 3 millimeters. The height, this measurement here, is the same as that measurement there, 7 millimeters over 2. So 3 times 7 is 21, divided by 2 is 10.5. We need to add these two together. We need to add the 84 square millimeters and the 10.5 square millimeters. Luckily, we probably know how to add. So we can get to 94.5 square millimeters. That's our total surface area. So the 84 is in here and the 10.5 is in there. And altogether, we reach 94.5. Last example for today is this circle cut out of another circle. So we're going to find the blue area, the shaded area. we're going to take the area of the big circle minus the area of the small circle. Because it's like we have this big circle and we chop another little circle out of it. The area of the big circle is, well, pi r squared, which is great, as long as we know r. 5 meters, that's not r, that's the diameter of the small circle. 3 meters, that's not r, that's the, I don't know, length of this pathway or rim or whatever this thing is. The radius of this circle goes from the center to the edge. So for the big circle, that's going to be from here to here, which we know if the diameter is 5 all the way across, the radius has to be half of that. So the radius is, for the big one, diameter, this is a small one, sorry, diameter over 2, which is 5 meters over 2, which is 2.5 meters. That gets us this far. That gets us from here to here. That's 2.5. But that doesn't get us the whole way. The whole way means we've got to go across this border. And we know that all of these measurements that I'm skillfully drawing in here are 3 meters long. So we need to add in 3 meters. That's here. This is also 3 meters. So the radius of the big circle is 2.5 meters, which is the small circle radius, plus the 3 meters it takes you to get the rest of the way to the edge. So 2.5 plus 3 should be 5.5 meters. So for the big circle, pi r squared is pi times radius, 5.5 meters, squared. So 5.5 squared times pi is 95. That's the big circle. The whole big circle, but we need to chop a little bit out of the middle. So we need to find the radius of the area of the small circle, which again is going to be pi r squared, but a different r. This r we already found out, 2.5. We know the diameter of the small one is 5, so this one here is going to be 2.5. So pi times 2.5 meters squared, 2.5, square it, multiply by pi, and we get 19.6. Square meters. That's the area of the small circle. If we subtract them, we cut one out of the other. That's 95 square meters minus 19.6 square meters, which is 75.4 square meters. So that would be the shaded area for this shape. So here's 6 examples from today. Hopefully they help as you work through your assignment or your homework.